As shown in figure, cars A and B are undergoing uniformly accelerated motion with different acceleration on a straight road. Car A and B pass P and Q at the same time with speeds VA and VB respectively. Both reach baseline S at the same time. The direction of acceleration for both cars are same, but the magnitude of car A's acceleration is 2/3 the magnitude of car B's acceleration. The time taken by car B to travel from Q to R is half the time it takes for the car B to travel from R to S. The distance traveled by the cars between P and Q, between Q and R, and between R and S is same and is equal to L. So this is the basic figure. The car is it is divided into, you can say, 4 parts: P, Q, R and S, and each section is equal. It means the length of section P between P and Q is L. Similarly, between Q and R is also L, and between R and S is also L. There are 2 cars. One car starts from A at same time means, and another car is at B. So distance, and they ultimately are going to reach this point S at the same time. Okay, so it means car B travels a distance of total 2L and car A travels a total distance of 3L. And keeping in mind the time taken by both cars A and B to reach this point S or baseline is same. And the rest of the things we are going to discuss. Another thing is given that the acceleration ratio is 2/3. Okay, so the rest of things we can discuss as we are going to move forward in the question. So we start that if total time of car A from P to Q is 3t, then the car B is also going to take the same time, that is 3t, from B to our S. And we also assume that let the velocity of car A at the baseline S is v1 and the velocity of car B at baseline S is v2. We say initial velocity in both car A is given as VA, and for VB, for car B it is already given as VB. We say at baseline S, let the velocity of car A is v1 and car B is v2. This is the velocity at the baseline S. So we have car A having a velocity of v1 and car B having a velocity of v2. And total time taken by each car to baseline S is our 3t. Okay, so car A is going to take time 3t, as well as car B is going to take 3t from Q to S and car A from P to S. And the total distance traveled by car is 3L, where the distance traveled by the car B is 2L. Distance traveled from P to S by car A is 3L and by car B is 2L. Distance traveled by P to S by car A, and for car B it is from Q to S because car B is already at Q. So we can write the equation that the total distance, yeah, we can say displacement, is equal to average velocity divided by time taken. So we can write that the displacement is equal to average velocity multiplied by time. So we can rewrite this formula for car A. Car A total displacement is its 3L. This will be equal to VA is the velocity at P and V1 is the velocity at S divided by 2 multiplied by 3T. And for car B, distance traveled is 2L and the velocity is VB and V2 divided by 2 and time taken is also 3T. So both the cars are taking time 3T. We can also write equation for kinematics for car A as well as car B. Equation of kinematics for car A and we are going to use V is equal to U plus AT, and for car A the final velocity is V1, initial velocity is our VA, plus let us suppose the acceleration is given as AA and time is our 3T. And please keep in mind that the ratio, or we can say acceleration of A to acceleration of B, the ratio is given as 2:3. Therefore, we can write from here that acceleration of A, we can write it as 2A, and acceleration of B, we can write it as 3A. So we substitute it here, we get V1 is equal to VA plus acceleration of A is 2A, so this comes as plus, and we have this as 6AT. Similarly, we can write for car B also. For car B, the velocity is our V2 is equal to VB plus acceleration of B, and time is it's also 3T. We substitute the value, we get our V2 is equal to VB plus 9A multiplied by T. So this is another equation for the kinematics. Now here it is important to understand that how the acceleration is going to play a very important part in the, you can say, both the cars. Okay, so let us discuss the acceleration part in detail. And we know that the distance traveled by both the cars is same. Distance traveled by different distance traveled in same time. Time taken is 3T, whereas the distance traveled by A car is 3L and by car B is 2L. Okay. So we start for, we can say, the acceleration, we say that different distance is traveled in same time. And we can write that for car A, distance traveled is 3L. Distance traveled is our 3L, and time taken is 3T. Whereas for car B, distance traveled is 2L, and the time taken is once again same, that is 3T. And also they start from different points. From here we can draw conclusion that from the figure also, let me write it here, that car A starts from point P, whereas car B starts from, I think it should be Q, point Q, whereas car B starts from point Q. But both the cars reach point S, that is the baseline, in same time. Okay. But both cars reach baseline S at same time. So therefore we can say that the car A travels further, that's for longer duration of you can say distance as compared to car B. You can say car A travels further that is 3L, whereas car B travels less, that is distance of 2L. So therefore we can say that car A takes longer to decelerate. Car A takes longer to decelerate, whereas car B decelerates more quickly. Along with this, it is also given that the respective accelerations, we can say car A has an acceleration of 2a, car A has acceleration which is equal to 2a, and car B has an acceleration which is given as 3a, because the ratio is 2:3. Car B has acceleration, and that is our 3a. And from this, the data that is given to us, we can clearly see both the acceleration are positive. Okay. So car A acceleration is also positive and car B acceleration is also positive. So from the look of this, it looks like that both the cars are accelerating, because the value wise from the given description, it is looking that they are having a positive acceleration. But the distance traveled by both is different in same time. Okay. We can say, but distance traveled by both is different in same time. So it means they should be decelerating relative to their initial speeds to reach the point S at the same time. So we can say from here, therefore they should be decelerating relative to each other to reach the point at the equal time. They should be decelerating relative to each other relative to their initial speed, to reach the point S at the same time. To reach the point S at the same time. Therefore, even though from the looks it looks like that the acceleration is positive, but from this discussion we came to conclusion that basically they are decelerating, so acceleration should be taken as negative. So we have to modify these two equations, that is the equation for this velocity v1 and the equation for the velocity v2. So we are going to write it again. We can say, therefore v1 will be equal to va minus 680 and v2 will be equal to vb minus 9at. This was the important part here. Now rest we can easily solve it now. We already know the two equations, that is our for car A and for car B. So let me write it again here because it is very far. So we know that for car A we get that 3L is equal to, we have this as VA plus V1 divided by 2 multiplied by 3T, and for car B we have 2L which is equal to VA plus V2, sorry, it is VB divided by 2 and multiply by 3t, and we divide them both. Okay. So this 3t, 2 and 2 cancels, L also goes away, and this gives us that 3 by 2 will be equal to VA plus V1 divided by VB plus V2, and it can be further written as 3 times VA, 3 times VB, 3 times VB plus 3 times V2 is equal to 2 times VA plus 2 times V1. Next, we are going to substitute value of V1 and V2, and V1 V2 is our these two equations. So let us combine this called as equation number 1. So we say using equation 1, we get our 3VB plus 3 times V2, and V2 is our VB minus 980 is equal to, we have 2 times VA plus 2 times V1. V1 is our VA minus 6AT. Now we try to solve them, and we get this as 3VB plus 3VB minus, and this is our 27 AT is equal to 2VA plus 2VA minus 12A times T, VB and VA. So we just sort it out. This becomes 6VB and this becomes 4EA. So we can write this as 4VA minus 6VB is equal to minus of 15AT. Let us call this as equation number 2. And let me draw the figure here again. So this is our point P, from car A starts. This is point Q from car B, PQR. This is our R and this is our S, and the distance between each is given as L, and total time taken by car A to reach here is our 3t, and for car B up till the baseline S is also our 3t. So we can write that, okay, in the question it is also given that the time taken by the car is half that of the other car. Okay, so we can say that for car B, time taken from Q to S is 3t. Time taken from Q to S is our 3t, but the time taken from R to S is 2t because it is given as half. Okay, so we can write time taken from R to S is our 2t. Therefore, from Q to R it will be t, obviously. Therefore, from Q to R the time will be t. And we say that at point R the velocity of this VB car our B car is given as VR. Say that velocity, let velocity of car B at R is given as VR. So once again we can write the basic formula that the displacement is equal to average velocity multiplied by time. Okay. So we can say therefore L will be equal to VB plus R divided by 2 and multiply by time taken T. This is for from Q to R. Similarly, we can write from R to S. So we can say from R to S. Distance travel is once again same, that is our L is equal to velocity at R is taken as VR and velocity at S for car 2 is our V2 divided by 2 and time taken is 2t. And we can just solve these two equations. So from here we can write that this gives us that VB, and we can also use the equation of kinematics. Let me write it first. So we can say from equation of kinematics, V is equal to U plus AT, and we can write that our VR is equal to VB, and we already know it is a plus AB multiplied by T. We substitute the values. VB, it is a deceleration of 3A multiplied by time T. So we got the value of our VR at point R. So now we substitute value of VR first in this equation and then in other equation. Okay. So therefore we can write, for Q to R, then we take it for R to S. So you can say from Q to R, L is equal to, we substitute the value, we get VB plus VB minus 380 divided by 2 and multiply by T. Let me solve it further. We can write this as L is equal to, we get this as 2 VB minus 380 divided by 2 and multiply by T. And similarly for R to S, from R to S, we get L is equal to VB minus 380 plus VB minus 980. Here we substituted both value of VR as well as value of V2. Divided by 2, and this is multiplied by 2t. So we get L is equal to, this will be our 2 VB and minus 1280 divided by 2 multiply by 2t. Now we can equate these two equations. So we can write, we get two VB minus 380 divided by 2 multiply by T is equal to 2 VB minus 1280 divided by 2 and multiply by 2t. So 2 and 2 cancels out, t and t goes away. So we can write this as 2vb minus 380 will be equal to, multiplying by 2 inside, we get 4vb minus, and this is about 24at. Now vb and vb, we combine them, we get this as 4 minus 2 vb is equal to minus of 24 plus 3 multiplied by at, and this gives us that vb, or rather sorry, twice vb is equal to 21 times 80. Let me write here. This gives us that vb is equal to 21 divided by 2 and 80. We got the value of vb, and now we can find out value of va also. Okay. We can use the equation that but 4 times va minus 6 times vb is equal to minus 15 times 80. Now we substitute value of vb here. We get 4 times va minus 6, and this is for 21 divided by 2 times 80 is equal to minus 15 times 80, and this 2 goes with this 3. So we get this as 4 times va minus, and this comes as 6380 is equal to minus 1580. We are almost done with the question now. So here we get our 4va will be equal to minus 15 plus 6380, which is coming as 48 times 80. So va will be equal to, this comes as 48 divided by 4 times 80. 48 divided by 4 times 80, and that is equal to 12 times 80. So we got the equation for va, and we also got the equation for vb. We simply, because we have to find the ratio, so we can say ratio va by vb, we get this as 12 times 80 divided by, and vb was 21 divided by 2. We have 21 divided by 2 times 80. 80 and 80 cancels out, and we can write this will be equal to 24 divided by 21, and which can be further simplified as this goes by 3, 8, and this goes by 7. So we get the answer that the ratio va upon vb will be equal to 8 by 7. So this is our final answer. So we can say this is the ratio of velocity of A to the velocity of B. This is the ratio of velocity for car A to car B at point P. Not at point, but with respect to points P and Q. With respect to points P and Q, because they have different starting points. Anyway, it's a ratio, it doesn't matter which points we are taking, because the velocity will always be remaining in the ratio 8:7. 7. But anyways, this completes the question. Thank you.